Good afternoon, everyone. My name is David Zabka. I just want to welcome everybody here to this week's 30 at 3 Live. Today, what we're going to be covering is moment connections, just some different functionality with the moment connections, different things with how to set some of these up, and just a couple different things to get the results that are required for your moment connections. So I'm going to start off real simple here and just zoom into a framing situation here. Just going to kind of look at our beams here framing to this column. I believe we got in this case it's a W 8 by 48 that we'll look at. Or actually what I want to do is actually look at this 10 by 49 over here. I'm going to start off with that one. So first what I want to do is I'm going to go ahead and apply a welded moment connection to the beam framing to my column flange. So I'll go ahead and edit that. I use a shortcut key on my keyboard for edit and then simply select that material. So first thing I need to do here to actually apply a moment connection, you'll notice my moment type is currently grayed out. That will always be the case when your connection type is auto standard. We need to change that to something other than auto standard. So I'm going to set that to a shear connection, and now I can specify what type of moment this is. I'll go ahead and select welded. And now I can say OK. When I do that, then we notice the connection changes a little bit, especially the connection framing into our web. We can see that SDS2 Connect automatically pulled that connection back. It changed it to a shear tab extending out past the flange. For erection purposes, when we're designing that connection, we have doublers and stiffeners designed in that column. So again, for erection purposes, SDS2 Connect goes ahead and pulls that shear connection out past the flange. We can see some of our end preps changed a little bit on the beam with the moment applied to it. Currently, we can't actually display all the end preps required 100% in Revit. When these get transferred, or if they get transferred to SDS2, in that model you would see these displayed 100% correctly like they need to be. We are still actually applying those and taking those into account. We can actually change those, or we can just see those in the edit window here. If I go into the end preps, okay, we can see we have a top flange and bottom flange operation. We're doing a cope field weld, number 3 in this case, and then we have the different values of that we can change there. So we also have a moment section in here. If I select moment, I can actually disable the doubler and stiffener check. So basically what that would do if I turn those two options off is SDS2 Connect is going to kind of ignore the checks to see if doublers and stiffeners are required in that column. You can see our connections framing to the web go back to what they were before. So we won't get those then. I'm going to go ahead and turn those back on. Notice we have an option for column web doublers. So what we're doing there is determining the side of the column that those are to be placed on, near, far, or both sides. Going down here, I'm going to skip seismic for now. The reentrant cut, okay, this is going to determine the end prep to be used. We have either alternate 1, which should be used for rolled shapes, or we have alternate number 3, which should be used for built-up shapes. That's kind of based on information from the AISC 13th edition. If you look at page 16.1-328 is where we're taking that information from. So in this case, alternate 1 should actually be used since this is a rolled section. So I'm going to change that to alternate 1. And again, we're not able to display the end preps here in the Revit model like we would be able to in SDS2. Again, like I said, if this is transferred to SDS2, you're going to actually see 100% there, the end preps applied to that. Again, we're taking them into account. We are figuring those. You can make changes to those through the end preps. The display of them is just not 100%, like I said. So now, the default size of these end preps is going to come from our setup. And when setup opens here, under weld design criteria, the moment connections section here is going to determine the settings or the default size that our end preps are. So everything from weld gap for field welds down to groove angle is going to apply to the reentrant cut alternate 3. All the other options here with alternate number 1 are going to apply to alternate number 1. Here we're just specifying the default that we want applied when automatic is set for that option that I showed you in the edit window and change. Okay. Now, if in my design criteria I have seismic moment connection design turned on, or I can also turn this on a case-by-case basis in the edit window, the end prep information is actually going to come from seismic weld access hole configuration. So we're going to be using those values then to determine how those end preps are done. And these settings here, the default settings that we have in here, these again are taken directly from Table 1-1 of the AISC Seismic Design Manual. So like I said, the defaults are taken directly from there. We can change them in here if we need, but hopefully we shouldn't have to. Okay. Now, another thing, I'm just going to go ahead and select this column, and I'm just going to rotate that 90 degrees. We're going to go ahead and SDS2 Connect is going to basically redesign these connections on the fly as we rotate it here. We're going to get then our welded moment into the column web rather than in the flange like we're seeing at this point. Okay, so we can see we get a little bit different connection design there then to get that connection. Now, I'm going to back up one step here and talk about the doublers and stiffeners again. I should have showed you back in setup here kind of how we size the doublers and how we size the stiffeners. There's a section in our setup under moment plate design criteria. These settings are going to determine how our doublers and our stiffeners are sized. So the top options here are going to apply to all of our stiffeners. And then we have different tabs depending on whether we're framing to the column flange or the column web. Our doublers and stiffeners could be designed just a little bit differently. And we have options for the locations of those, how those are actually placed in there also. Okay, I'm going to go ahead and edit this connection again, and we'll look at a bolted moment now. So I mentioned the seismic moment connection design earlier. So here's where under the moment section, if we specifically set that to yes, we're changing that to be designed as a seismic moment there. I'm going to go ahead and change to a bolted moment here. And when I do that, notice at the bottom of the window, then I get a failed message tells me my member moment strength exceeded. So what's happening here is the reason this is failing is the automatic load that's calculated here for the moment. This is actually 85% of the max beam moment, but that's before holes are present in the flange for the moment plate. So after those holes are drilled or punched in that, the flanges for our moment plates, the max moment of that is reduced. Basically, you're comparing the gross to the net area, basically, is what the problem is. So this is actually changed back in the design criteria that we were in earlier. There's a field called base beam design moment on percent of maximum allowable moment. You can change that in there, adjust that if need be. I'm going to go ahead and just lower the load here for our case. So I'll do minus 1,000 kip inches. We can also change the display to kip feet if we want to work in kip feet. But now we should see we get a connection. We no longer have that failed message. The other thing to take note of here is I typed in the minus, so the plus and minus would determine the direction of that moment, so that is important there. Okay, and then we get our moment connection into the column web there then. Going back in there just to show you a couple other things quick. Back in the moment section, so we can choose to do moment plates, or we can also do that with an angle material to the flanges. The bolt type in the bolt diameter here that we can change, that only applies to the bolts in our flange plates. If you want to change the bolt type or diameter for the shear plate in there, we're going to go back under the connection type and change the non-moment type and diameter here. Okay. Last thing then is I'm going to go ahead and switch to an end plate connection that's doing bolted. We get a little failed message down here about our gauge. So I should be able to change my gauge in my connection specifications here. It'll probably also complain about the end plate grade. AISC specifies the minimum yield stress of the end plate material must be less than 50 kips. So I'm going to go to A36 there. And probably going to need to rotate this column back so we're framing into the flange again. Do that quick like. So now we see our end plate moment in there. Again, you get your stiffeners and everything in the column there. Now, I'm going to edit that connection one last time, go into the moment section, just show you quick like the additional options when we have an end plate moment. First off is the AISC or MBMA connection type, and then the location we can do top flange only or top and bottom, and we also have an 8-bolt versus 4-bolt pattern. So might change that to top only, doing 4-bolt. We get a redesign on that. Okay. Last thing, and then I'll open it up to just any and all questions for Connect related, is I'm going to show you the design calculations report, just so you have an idea, so you can see it. So I run that. We get all of our limit states and everything, including for all the moment strengths and all that. And we can also go ahead and view the extended report in Firefox. That's going to actually include the formulas, how we came up with our different results in there. Okay, so with that, I will go ahead and turn it over to questions here. We got about another 15 minutes or so. So if you guys have any questions, can be related to what we looked at today, or if you just have any other questions related to SDS2 Connect, feel free to ask any of those also. So, go ahead and type that into the questions part of the webinar toolbar. So one of the questions here is that the end preparations are not shown in the model, but how can they be detailed in Revit drawings without exporting to SDS? It's a good question. You know, we're not, the thing about SDS2 Connect is working in the Revit environment is we're not actually trying to create a manufacturing model that you're going to be able to detail in Revit. So you may be able to modify the sketch somehow. If you make a 2D drawing of that, that would probably be something that you're going to have to modify your 2D sketch of to actually get those to be shown there 100%. The reason why we can't really display those 100% is because of some of the limitations of Revit families and how we have to accomplish those. It's really not possible to do at this time. So. Another good question here is somebody just asked if what if I change the beam size? So that should be no problem. If I change the beam size, we're going to go ahead and update that connection based on that beam size. So right now we have a W18 by 35. Maybe I'll just go with a 21 by 44. Okay. And we can see our connection updated right as we changed that. So changing the beam size should be no problem in this case. So a couple more questions here. One of them is, are there connections that cannot be analyzed in SDS2 Connect? The answer to that would be yes, there are connections that we cannot design and check. I guess I would have to, you know, one of the big ones I'll just throw out there because it's came up a few times in the last couple of weeks is shear through plates, shear plates to a tube column with a through plate. We can't design that when there is actually an axial load applied. So that would be just one case where we don't analyze a connection. There's a second part of that connection then also is, can I build a specific connection analyzing an existing condition and be guaranteed that it would analyze it? I guess in that case, I'm not 100% certain what you're asking for there. Sounds like you're kind of looking for maybe parametrically created connections. And in that case, the answer to that would be no, we can't do that. We can really only design connections for what's programmed into the program currently. So I might contact you just a little bit later on that to get some more information on it, though. So, another one is, do you support dog bone or any of the proprietary moment connections? In that case, again, the dog bone is something that we don't support at this point. So, Another one, can column base plates be designed for columns connected to concrete? Again, SDS2 Connect right now is strictly designing connections for your steel members. So we're only designing steel to steel. We don't do any concrete at this point. Okay, do we have any? Another one, what about column splices? So column splices is something that we do. I do have a couple examples in this model here. So we can see we have a column splice there. You know, we can get web plates in there. We can do a welded. We can provide a butt plate in there if you need. So in this one, maybe if I throw in here, I'll apply a horizontal shear load to that. That should require then web plates. So we see we get the web plates. Have a few different options with those also. So column splices is something that we do. So another question here, can we create a single shear plate on a tube section such that a wood beam can connect? So I think what you're asking for here, I'll go ahead and so hopefully I have a tube beam loaded in here. I thought I did. So I have a HSS 6x4x1/4 section here. I'll go ahead and throw this in to kind of demonstrate that. And we could do, right now we're getting a clip angle there. I should be able to change that to shear. Use my 8x8 so I can get an extra row of bolts in there. We should have, now I'm probably falling off my column, so it's going to fail that. But yeah, we should be able to, yeah, I'm not fitting my column now. But we should be able to, what we would do in that case is two plates on either side of that tube column. Go 12x40 here, change the size of that column. Maybe we can fit on that column then. But yeah, so we should be able to get shear plates on, like I said, it'll create those on either side of the tube column for us. So we can do something like that. Another one, what about beams that are classified as joist in Revit as opposed to girder? So in earlier versions, we only designed connections for the ones that were girders. We have changed that, so we will design the connections for beams that are classified as both joists and girders. So that's, like I said, that was something in earlier versions that we didn't do, but we changed that so we can design for those now. So. Okay. Can SDS2 create and analyze a shear connection to a column web with an extended configuration and optional stiffeners, AISC manual figure 10-12? We should be able to create that, and as soon as I'm done designing up here, I'm going to come back to that tube here for us also before we're all finished. I'm just going to go over here to where I'm framing into a column web. So if we want a shear connection extended out past that flange, hopefully this is the same thing you're referring to here. So in this case, if I change my connection to a shear, and I go into the connection specifications, I have an option to extend that past the flange. Okay, we're going to go ahead and get that extended past the flange. Now, I don't know if we're doing exactly what you're looking for there as far as when you're referring to the AISC manual figure 1012. That's something I would have to look into, and I will, and get back to you on that one for sure. So. Okay, another one is what about sloped framing? So not exactly sure what you're looking for with sloped framing. I have a couple examples in this model. So if I look at some of my beams over here that are sloping, we got the ones framing into what would be our roof on this building here. So that roof is even sloping. Looking over here at these, so we can see we have connections here. Again, the end preps in this case is something that we can't do 100% correct. If I edit that and take a look at that through the end prep, I can see we are getting the correct coat in here applied, and as we transfer that downstream to the manufacturing model to the detailing, we're going to actually see those in the model. Then again, it's a case where we're limited to what we can do with Revit's families and how we display those. So sloped moments, so if we have sloped moments, we can do that also. Okay, we probably got time for one more one more question here, if anybody's got one. And again, there's quite a few questions coming in, so if I've skipped somebody's, I'll try and get back to you afterwards to make sure nobody's forgotten. So another question here is, how much does the addition of the connection bloat the model? So the answer to that, we have done quite a few things to keep the model size down. One of those is we give users the option to actually generate connections with bolts. So if you have that turned off, we don't actually generate the bolts for display in the model. They are taken into account. We calculate the size and how many rows and all of that. We just wouldn't display those in the model. So that's one thing we've done to kind of prevent that bloating of the model as it's typically referred to. Another thing we've done here, I'm just going to turn my detail level down to fine. You'll notice there are no holes actually generated in there, so we haven't actually generated any holes. Again, we take into account whether it's, you know, the hole type and how many rows of bolts and all that. So all of it's taken into account. It's just not being displayed. And since we did those couple of things, the model is not bloated too terribly much. Is it going to slow your model down a little bit? Yeah, maybe. Well, like I said, we kind of took a few things into account there to help prevent that. So. Okay, and with that, I know, again, like I said, I think I missed a couple of questions. I'm going to go back through these afterwards, and I'll send out, make sure that I do get everybody's answered. We're about out of time here for this afternoon. So most of you may have seen the promotion that we've had on Facebook and Twitter, I believe is what they've been promoting it on. I don't have my sales sidekick with me this week to mention it, but what we're doing this week is if you purchase Connect before the end of business on Monday the 12th, so it'll be 5 p.m. on Monday the 12th. We'll give you $250 off the first 5 licenses that you purchase. So just kind of a promotional deal for attending the webinar here. And the way that we'll do that, I believe, is they're going to, you'll have to purchase for the full price on the website, and then we'll basically refund you that money afterwards. So if anybody has any other questions other than what we've had answered here or whatnot, feel free to contact myself here at Design Data. I'd be happy to help you out. So thanks for attending, and everybody have a good day.